Aloha! DeepSeek takes the world by storm for its low-cost yet high-performance development. Is this AI model building approach a paradigm shift or just an enhancement of existing technologies? Let's explore this together. Two of the key techniques behind its success are reinforcement learning and distillation. However, these methods are not new. AI researchers have been using them for years. What makes DeepSeek groundbreaking is how effectively it applies them to build a powerful yet efficient large language model. I have briefly introduced the concept of reinforcement learning in another video entitled, Behaviorism in AI. Never say never, which is accessible in the same channel. In the following I will focus on distillation. Distillation is like how a student learns from a great teacher. Instead of figuring everything out from scratch, the student studies the teacher's notes and absorbs the key lessons, saving time and effort. This is what happens in knowledge distillation. A large AI model, known as the teacher model or the parent model, which has learned from vast amounts of data, transfers its knowledge to a smaller AI model, known as the student model or the child model. The goal is to make the smaller model almost as smart but much faster and cheaper to run. DeepSeek's breakthrough isn't about inventing new AI techniques, it's about mastering existing ones. By combining reinforcement learning for deep intelligence with distillation for efficiency, it achieves high performance at low cost. This blend of learning from experience and learning from an expert is what makes DeepSeek stand out in the AI landscape. Thus, DeepSeek's R&D can be epitomized to reinforcement learning and distillation. DeepSeek has other technologies in the AI model, of course. Please keep in mind that this video is just a simplified summary. OpenAI, supported by major investor Microsoft, complained that DeepSeek may have illicitly distilled OpenAI's information. Microsoft's security researchers detected unusual activities in the past, where individuals allegedly linked to DeepSeek were extracting large volumes of data using OpenAI's API. This behavior suggests that DeepSeek may have bypassed usage restrictions to gather substantial data, potentially violating OpenAI's terms of service. I carefully examine claims from all sides to ensure a fair and objective assessment. While simple and generic questions may produce similar responses across different AI systems, I conducted an informal test comparing ChatGPT, Claude, Perplexity AI, and DeepSeek by posing a fairly complex question related to instructional technologies. This included topics such as Seymour Papert's logo programming, hypertext, multimedia, web-based instruction, and course management systems, each covering a broad range of information, making it nearly impossible for two models to generate identical responses. While the answers from ChatGPT, Claude, and Perplexity AI varied significantly, the responses from ChatGPT and DeepSeek were strikingly similar. Because of limited space, I am unable to display all the results. Instead, I will present selected excerpts. This is the analysis of web-based instruction by ChatGPT. The advent of the Internet brought hopes of democratizing education through web-based instruction. Massive open online courses, MOOCs, epitomized this promise, with institutions like MIT and Stanford offering free courses to millions. While these platforms achieved significant reach, their completion rates remained dismally low, often below 10%. MOOCs largely benefited highly motivated, self-directed learners while failing to support those who needed guidance and structure the most. This is the answer from DeepSeek. The advent of the Internet brought promises of democratized education, with web-based instruction enabling access to knowledge for learners worldwide. While platforms like MOOCs, massive open online courses, have made education more accessible, they have also faced criticism for low completion rates and a lack of meaningful engagement. Many learners struggle with self-directed online learning, and the absence of personalized support often leads to disengagement. This is the analysis of hypertext and multimedia by ChatGPT. The rise of hypertext and multimedia in the 1980s and 1990s was heralded as a way to create richer, more engaging learning environments. Proponents argued that students would benefit from nonlinear access to information, enabling personalized learning paths. However, the results often showed cognitive overload rather than enhanced understanding, as students struggled to navigate and synthesize large amounts of unstructured information. Furthermore, multimedia often prioritized flashiness over substance, contributing little to deeper learning. DeepSeek yields a similar answer. In the 1990s, hypertext and multimedia were touted as tools that would make learning more interactive and engaging. Proponents argued that these technologies would allow students to explore information in nonlinear ways, catering to individual learning styles. However, the reality was often overwhelming for learners, who struggled with cognitive overload and disorientation. Moreover, the lack of structured guidance in hypertext environments sometimes hindered rather than helped learning. For me, it is unsettling. If two students submitted papers this similar, I would definitely initiate an academic integrity investigation. My initial speculation is that DeepSeek may have used ChatGPT as a learning source. But this issue awaits further investigation. It is still premature to draw a firm conclusion. Nonetheless, even if DeepSeek distills OpenAI's information, it doesn't imply that DeepSeek has no merits. In the world of artificial intelligence, the current norm is simple: bigger models are smarter. Typically, a small AI model, often referred to as a child model, is inferior to a larger parent model because it has fewer parameters, less training data, and a weaker ability to generalize across tasks. However, DeepSeek has defied expectations by developing a smaller yet powerful model that can compete with ChatGPT. How is this possible? The secret lies in advanced distillation techniques, superior data strategies, and architectural innovations. Consider this metaphor. After compressing the original photo into a JPEG image, the photo becomes fuzzy. We call it lossy compression. Naturally, a lot of details would be lost. This is the fundamental problem with distillation. When a smaller model learns from a larger model, it often lacks the full depth and intelligence of the original. Yet, DeepSeek overcame these challenges and created a compact but powerful model. Let's explore how. First, distillation is traditionally about compressing knowledge, but DeepSeek likely refines the process with advanced techniques such as iterative and progressive distillation. Instead of distilling knowledge in one step, DeepSeek may use multi-stage distillation. In stage 1, the large parent model teaches an intermediate model. Next, the intermediate model then trains a final compact model while preserving critical knowledge. Each step prioritizes key insights and filters unnecessary complexity. By doing so, instead of blindly shrinking the model, it adapts intelligently while keeping essential capabilities. In addition, DeepSeek's smaller models might continue to train themselves after initial distillation. This process allows the model to reinforce key patterns, improving performance without needing the large parent model anymore. It is likely that DeepSeek also employs a superior data strategy. A model is only as good as the data it's trained on. DeepSeek likely leverages higher quality datasets rather than just copying everything from the parent model. Instead of overwhelming the model with huge but noisy datasets, DeepSeek may focus on high-value, high-impact training data to maximize learning within a smaller model. While conventional wisdom suggests that smaller models are weaker, DeepSeek shows that size isn't everything. By combining advanced distillation, reinforcement learning, superior data strategies, and efficient architectures, it creates a compact but powerful AI that challenges even the industry's biggest players, including ChatGPT. DeepSeek's success lies not in building the biggest model, but in building the smartest one with the most efficient learning strategies. This marks a new era in AI, where intelligence is not just about scale, but also about optimization and refinement. No doubt DeepSeek has sparked a wave of excitement in the AI community, with some hailing it as a Sputnik moment or a wake-up call that challenges the dominance of larger models. However, if we strip down its core methodology, distillation from larger models, the question arises: is this really a paradigm shift, or simply a more efficient way of leveraging existing AI breakthroughs? Knowledge distillation does not seem like a paradigm shift. It fundamentally depends on the existence of larger, more powerful models from which smaller models learn. No matter how refined the distillation process becomes, it still requires a parent model that has undergone expensive, large-scale training. This means that companies at the forefront of AI development, those capable of investing billions into training foundational models, remain indispensable. If distillation-based approaches like DeepSeek's become dominant, a possible unintended consequence is that many smaller companies might wait for others to build large models first, then distill their own versions later. This could discourage massive investments in foundational research, as the economic incentive shifts from creating original breakthroughs to refining and repackaging them. However, this perspective overlooks some crucial aspects of AI development. First, while distillation starts with knowledge from a larger model, it does not necessarily end there. A distilled model is not merely a compressed or stripped-down version of the original. It can be further refined, retrained, and optimized in ways that make it superior for specific applications. Techniques like self-distillation, reinforcement learning from human feedback, and architecture optimizations allow these smaller models to evolve beyond their original teacher models. Additionally, while it is true that foundational models require massive investments, the reality is that not every AI use case requires a behemoth model. If distillation allows smaller, more cost-effective models to perform on par with, or even surpass, larger models in targeted tasks, this could democratize AI access. Think of it this way: while you might need an SUV for occasional off-road adventures, a sedan is all you need for your daily commute. By the same token, a distilled LLM may be sufficient to solve 90% of your problems. Instead of AI being monopolized by a handful of tech giants with the resources to train massive models, companies, startups, and even individual developers could leverage distilled models to build powerful AI applications without breaking the bank. In this sense, DeepSeek represents a redistribution of AI power, making it more accessible to a wider range of innovators. Even if distilled models become dominant, the market for large models will not disappear but will increase, because computing efficiency will lead to increase in demand for more computing. This phenomenon is known as the Jevons paradox, a notion introduced by English economist William Jevons in 1865. For example, increased fuel efficiency of internal combustion engines makes driving cheaper per mile. As a result, people drive more often and longer distances, increasing total fuel consumption. In response to distilled models, companies investing in foundational AI research might shift their business models to focus on licensing their models for distillation, much like how chip manufacturers develop cutting-edge processors that others refine and integrate into specialized devices. Instead of one-off blockbuster investments in AI, we could see a more sustainable ecosystem where large-scale models are periodically updated and sold as knowledge bases for the next generation of distilled models. Ultimately, DeepSeek's approach may not eliminate the need for billion-dollar foundational models, but it reshapes how AI is developed, distributed, and utilized. It emphasizes efficiency over brute force and challenges the assumption that bigger is always better. Whether this represents a true paradigm shift depends on how we define transformation. If a paradigm shift requires a completely new approach to AI, then DeepSeek is perhaps more of an evolution than a revolution. Nonetheless, DeepSeek may change how AI is accessed, refined, and commercialized. DeepSeek, and the rise of highly optimized, cost-effective models, may indeed change the game. Perhaps it is more appropriate to call it a game changer. The real test will be whether DeepSeek's approach remains competitive in the long run. If it consistently produces distilled models that challenge or outperform larger ones while being cheaper and more efficient, the industry may move toward a future where innovation is not measured by raw parameter counts but by how much intelligence can be extracted from a given amount of computational resources. While DeepSeek's claim is promising, it is too early to fully embrace it without verification. However, ignoring it outright would also be a mistake. That would be a shift worth watching. Mahalo.